Hello and welcome. My name is Micah Silverman and I work for Snyk as Director of DevSecOps Acceleration. And today I'm here to talk to you about the Log4Shell exploit that's been in the news for the last week. We're going to take a deep dive into a proof of concept example and really look and see what's going on behind the scenes. But before we get into that, let's take a look at where this exploit came from and how this came to be. It kind of set the internet on fire for the last week. Now let's start with my poorly drawn diagram of what's happening here if you're using log4j less than 2.15.0. Where we start is you can drop a string into a log message that looks like a Jindy LDAP string. And because of some additions to log4j back in 2013, as we'll see in just a moment, it'll actually resolve that URL and go and fetch an LDAP response in this case. Now, before we get into the mechanics of this diagram and what's happening, let's take a step back and talk about this pile of technology that's involved here. Jindy, the Java naming and directory interface, is one of the many Java abstractions that we love that allows us to write kind of uniform code that plugs into a variety of backends. So I could be talking to DNS, I could be talking to RMI, I could be talking to LDAP, and I get this nice uniform way to communicate with it. We probably, if you're a Java developer, you probably have a lot of experience in this realm dealing with JPA, like the Java persistence architecture, where you can have MySQL or Postgres on the back end, and you just write your POJOs and everything kind of hangs together. Well, this abstraction is all about directories. So Jindy, in this example, we're going to be using Jindy to talk to LDAP, Lightweight Directory Access Protocol. And LDAP allows us to store information about people, about organizations, and even about devices on networks. And it's what Microsoft Active Server, is that right? I think that's right, is based on. We'll return to my poorly drawn diagram in just a moment, but first let's get a little history lesson on how this pile of network activity found its way into the humble logger, log4j. If we jump in a time machine and go back to this request from 2013, we can see that a use case was identified, a request was made, a patch was put up, and it was integrated. Now I want to take a step back and say, no shade to the reporter and the person who wanted this feature integrated and the person or persons who ultimately approved it, because this is the double-edged sword that we deal with every day with open source project. We have lots of contributors. That's usually great. There seemed to be a really good use case back in the day, back in 2013, and it led to some unintended consequences, which we're now dealing with for this past week. But back in 2013, we can see that a use case was identified. We have some nice references here. A patch was put up and approved. There was a little bit of back and forth conversation, and the support for Jindy lookups was integrated into 2.0 beta 9. Okay, so this is 2013, 8 years ago. And now if we take a look, we can go over to 2016, 3 years later, and at the Black Hat conference in that year, a nice demonstration was done that had two of the three components of what we now know as Log4Shell, and that is Jindy and LDAP. The only thing missing in this demonstration was Log4j, although it was sitting there waiting to be exploited at this point. But this demo was all about showing how you could get a remote code execution by abusing Jindy and LDAP. So the point here in this little history lesson is that this has been around for a while, and this is kind of the funny thing about vulnerabilities and about exploits, is they're often sitting, lying dormant, And in the worst case, maybe they've been quietly exploited over the years and we just haven't known about it until recently. So in terms of the timeline of this Log4Shell exploit, we're in the middle right now. The beginning was in 2013. Then as of last week, things blew up a little, or a lot, bringing us to the middle. And now, from here on out, we're going to be looking at not only patching and fixing and making sure that we don't get attacked through this vector, but we're also going to be monitoring and seeing a spike in attack attempts and perhaps successful attacks, hopefully not. Okay, let's jump back over to my poorly drawn diagram and dive into what's going on here. So, in older versions of Log4j now, when this gets dropped into a logger message, it kicks off a JNDI interaction, and that makes an LDAP request over here to our evil LDAP server. Now, one of the cool and powerful and dangerous things about LDAP, aside from being able to store text information, like organizational or personal information, it can also store information about machines on the network, and it can also store Java class information. And so the response that comes back from this request is a particularly constructed response that includes a reference to a Java object. And we're going to see when we look at the code, there's an important separation in the code example where this class that gets returned from LDAP, or I should say the reference to the class that gets returned from LDAP, we're going to see that class is not in the class path of this demonstration. So this is kind of a wholly reconstituted class from the perspective of Java serialization and deserialization that is not in the class path of our example application. So what comes back from LDAP is a reference to an external Java object, and that triggers, as part of this Jindy stack, it triggers an HTTP request, and this serialized class is returned as a byte array, which is then deserialized. And again, this evil.class is not in the class path of this app. But by virtue of the way that Jindy works, we're going to see that this type of class is a factory, and a certain method gets executed on that class, and then it causes some mayhem. So without further ado, let's jump into the code and see what's going on here in Log4Shell goof. And again, I'll make sure that these links and references are in the comments section of our YouTube channel. So Log4Shell goof, it's part of this Java goof project. It's a submodule. This whole project is arranged as Maven modules. It's got its own nice README, so you can run this on your own if you want to see this in action. And there's a couple of different ways to run this. Because I want to dive deep into debugging so that we can really see the network calls that are going on, what I chose to do is to use a more modern JDK. I'm using JDK 11, and I'm using the Zulu version of Java 11 because it's been optimized for M1 Max. So yes, I'm bragging a little bit. M1 Max, M1 Pro Max is what I'm running this on, and this JDK is optimized for it. Now, you may have read that in newer versions of Java, there are still issues, but it's a little harder to do this exploit. But what I'm doing in this case is I'm explicitly passing in this command line parameter to trust URL codebase. By default, that's going to be false in this version of Java. You're still not fully protected by doing this, by the way, and you definitely don't want to do this. This is for demonstration purposes only. But it allows me, by using this modern JDK where I have access to all of the source code, it allows me to debug into Jindy and LDAP and see what's really going on behind the scenes. Let's take a look at our server. So the server part of this Log4Shell proof of concept, it has two pieces to it. It's got an LDAP server, a lean LDAP server, and a lean HTTP server. And this builds off of the work of some other great work that's out there, not the least of which is from my colleague, Java Champion, Brian Vermeer. He came up with really the first proof of concept for Snyk, and it works great. This kind of builds off of that. So this has both a lean LDAP and a lean HTTP server so that when the request is made, the full round trip can happen through this app. And the LDAP server is going to listen on port 9999 by default, and the HTTP server is going to listen on port 8000 by default, and we can see how this all hangs together in a sec. One other thing that I want to point out is when we look at the Log4Shell project, you can see that there are two Maven submodules. One is Log4Shell client, one is Log4Shell server. And the reason that it's set up this way is because I wanted to make sure that this evil payload was not in the class path of the client. The only thing that's in the client is main, and evil is served by our HTTP server on the server project, but it is not in the class path of the client. That's an important point that we're going to come back to in just a minute. So let's go ahead and look at our main class. This is where the action happens. And there's a few things going on here. Ultimately, a file called /temp/pwned is going to be written to. Now, because we want to run this as a demo, as a fully standalone demo, it does a little bit of checking. First of all, it's going to show you information about your JVM. Secondly, it's going to do a regular old log message. Nothing special here, no string to be interpolated, just test. Now, it's going to check to see if this temp file exists, and at this point, the temp file should not exist. So it's making sure that our kind of beginning state is the way that it's expected. Now, the next thing it's going to do is log a message that includes this Jindy string to be to then trigger this exploit. We're going to give it a beat just to make sure that the file actually gets written, since we are dealing with network, even though everything's localhost. So we give it a second, and now it's going to check to make sure that the temp file is there. Now the temp file should be there, proving that the exploit was successful. If you do run this on your own, after each run, you want to make sure that you get rid of the temp file, because the first thing it does is check to see if it's there, and if it's there, it's going to blow up. That's by design, because we want to prove that the file has been written newly and it wasn't just sitting there from some previous run. Okay, so I'm going to fire up my server here. All right, so I can see that the LDAP server is listening on port 9999 and the HTTP server is listening on port 8000. Next thing I'm going to do is fire up my main class here, and I have some strategic breakpoints set so that we can see what's going on. All right, first thing is we're in jndi lookup.java. Now, how did we arrive here, and where does it live? Well, this is the file that's part of Log4j core 214 and older. This is the file that was added with that patch request in 2013, and it's already been triggered because of the format of the string that we found in our main class. So now it's going to go and do a Jindy lookup. Let's see what happens next. All right, so now we're kind of deeper into the stack, and it's calling an internal lookup method Let's keep going. Now we're getting to some interesting parts here deep in the stack. We're in this directory manager class, and it's looking for this factory. It's getting this object factory from reference. Well, what is this reference that it's talking about? If we look here, this is what was returned from the LDAP call. This is the response that we got back from the LDAP call that was turned into this reference class. If we take a look at the attributes that came back, this is where things can get a little dangerous with the types of things that we can store in LDAP. We can see these 4 attributes are an object class, which is a Java naming reference, a URL, and then this factory attribute, which indicates that the factory is this thing called evil. In this particular case, the class name doesn't even actually matter. We're just calling it foo, because this factory pattern is going to take over in just a minute. Now, this is what was returned from our LDAP server, and if we scroll down here to the bottom where we send result, we can see that this is composed on the fly, where it's adding in these different attributes and sending that back as an LDAP result. And if we look at the console output, I can see that this LDAP reference sent us this redirect, this HTTP reference to this evil class. All right, let's continue. If I can find my place. Here we go. All right, so now we have this factory reference, and what we're going to do with that is we're going to get this object instance from the factory reference. So here's where the HTTP call is going to be made, and we're actually going to get this byte array back, and we're going to automatically, behind the scenes, deserialize that into an object. I think I went too far, so I'm going to reset. This is what we call the demo monster. First of all, let's just take a look. So, you've been pawned. That's the punchline here, because it was able to write this file /temp/pawned. All right, let's run it once more. Let's see, I'm going to go back to debug. I'm going to go to server. We're going to leave server right where it is. I'm going to clear it out. And let's run main once more. And we'll go through the process. All right, so here's our initial lookup into the weeds here. All right, here's our factory. Now let's dig into this get object instance. So, as I said before, this factory is a class that has been marshaled up, has been deserialized by making this HTTP call based on the LDAP response. Now that's a little bit to unpack, so let's revisit our attributes. We have these 4 attributes: object class, Java codebase, Java factory, which is the key one, and Java class name. So because it's a Java factory reference, the stack here knows that when it makes this call to 8000, it's going to deserialize that into this object instance, and it's going to be able to call, or rather this object factory from reference, and it's going to be able to call its get object instance method. Now, instead of stepping over that, let's step into that. And this is the big punchline. So we have this class evil that implements object factory. And if you notice what it's doing here, it's going to execute. So this is outside the JVM. It's going to reach out and launch a process in the enclosing operating system, Mac OS in this case. And it's going to echo pawned to /temp/pawn. Now this code here, this command could be doing anything. It could be exfiltrating your password file. It could be deleting your whole hard drive. At this point, it could be doing anything, which is the nature of a remote code execution vulnerability. And I also want to point out we're looking at the source code for evil Java, but we have access to that just because of the nature of the organization of the debugger in IntelliJ. Because we have these two separate projects, even though evil is not part of Log4Shell client, IntelliJ is still smart enough to recognize that it is available in Log4Shell server, and it can now show us here where we are. So I let this finish, and let's just jump back a spot. So this is part of the stack that's getting called automatically. So this whole Jindy process, which called LDAP, which referenced a remote Java object, which then went and fetched it and is now executing its get object instance. That's what is being executed right now. And if I go over to my terminal and I say /temp/pond, it's not there yet, but as soon as I let this finish, it was able to finish, and now it is there and it has been written. All right, so that was a nice little deep dive into the bowels of the JVM to see how this exploit all hangs together. Now, I don't want to just leave you in exploit land here, so I want to give you a few more resources that you can use to learn more about Log4Shell and to learn about how you can remediate the issue. So continuing on here. So here's the original CVE that was posted. This has a lot of information, a lot of background, maybe not as useful as some other resources. There's a blog post that I did that is more of an overview. What we just did here was more of a deep dive. This is more of an overview of what's going on. You can find that on our blog. We also fired up this really great, awesome Log4Shell repo. It's off of Snyk Labs here, and it's got a lot of resources along different dimensions: videos, explanation, detection and remediation. It's even got memes, which, keeps things a little fun. Maybe you've lost a lot of sleep this week, as I have, so you got to look at the memes. And one of my favorite resources that we've come up with, which is in this awesome Log4Shell reference, is this cheat sheet. It's a one-pager, and it goes through a lot of the different ways to detect and remediate Log4Shell. So I hope you found this useful. I hope you found it informative. Go to github.com/snyklabs. Look in the comments below to get a list of additional resources and a link to the repo that I used in this video. And until next time, keep on hacking.